Hello, sir. Good evening.
Yes, good evening.
Yes, sir. सर मतलब आज देर हो गया आपका मतलब मॉक चल रहा था शायद।
हाँ, मॉक चल रहा था, वो खत्म हुआ था अभी तो
हाँ
गया
सर।
था। 10 मिनट का लगातार मॉक चल रहे हैं ना,
हाँ सर।
कंटिन्यू मॉक चल रहे हैं ना, कंटिन्यू।
हाँ सर प्लीज। ओके
यस,
सर।
टुडे टॉपिक।
सर कोऑर्डिनेशन केमिस्ट्री कल जहाँ से मतलब
कल कहाँ तक
स्टार्ट।
कोऑर्डिनेशन फिनिश हुआ था हमारा कल?
सर कल आइसोमरिज्म तक खत्म हुआ था।
आइसोमेरिज हो गया था।
हाँ सर।
टुडे न्यू टॉपिक।
आइसोमर हाँ सर आइसोमरिज्म हो गया था। सर एक बात पूछना था पहले, मतलब इनऑर्गेनिक स्पेक्ट्रा का मॉसबियर वगैरह देखना होगा ना इंटरव्यू के लिए।
हाँ, स्पेक्ट्रो जो आप करेंगे, आप स्पेक्ट्रो तो मॉसबियर आ गया उसमें सारा, एनएमआर, यूपीआर।
स्पेक्ट्रा तो बहुत बड़ा है ना, इसलिए मतलब
तो आपने क्या
एक
रखा है? बेसिक चीजें बेसिक कर लेना,
हाँ।
उसके एप्लीकेशन क्या है, मॉसबियर का एप्लीकेशन क्या है, मॉसबियर स्पेक्ट्रोस्कोप।
That means structure determination basically.
हाँ,
I structure determination and yes sir, the main structure determination जो inorganic complex होता है ना, inorganic complex का structure determination होता है, आइसोमर शिफ्ट निकलते हैं। हाँ सर
यस,
अभी पढ़ रहा था इसलिए सर। हाँ
बेसिक चीजें करनी है, बेसिक ओनली। बाकी क्योंकि होल
ओके
केमिस्ट्री करनी है ना, अभी तो टॉपिक कर रहे हैं, उसके बाद रैंडम पूरा होल केमिस्ट्री रिवीजन करेंगे, तो पूरा स्पेक्ट्रो वगैरह सब कुछ करेंगे।
यस ओके।
सारी चीजें करेंगे, डिटेल में नहीं है, मतलब बेसिक आना चाहिए आपको, ये चीजें हैं। अगर पूछ लिया जाए आपसे कोई सा भी एनएमआर, ईपीआर, रोटेशनल, वाइब्रेशन, रमन, तो आप बता सके उसका एप्लीकेशन है क्या।
यस
सिलेक्शन रूल।
हाँ सर।
तो हम चलते हैं, लेट्स मूव ऑन द बोर्ड। आईयूपीएसी नोमेनक्लेचर, यस, एक्सप्लेन कीजिए।
यस सर। हाँ सर for IUPAC nomenclature, that means the coordination complex, the coordination compound can be three types. So if coordination compound can be of three types, that means it can be positive and it can be negative or it can be neutral also. Okay. So yes sir.
यस यस।
Okay. So positive, negative, and neutral. So for naming, first we have to decide that means the oxidation number of the element. That means oxidation number of the metal. Okay. First rule is to determine the oxidation number of the metal, and if the complex is positive, then the metal name is like same. That means metal name will be the same. Suppose I am taking CONH34 Cl2SO4. Suppose I am taking this one. So here the coordination complex is in positive. So positive coordination complex. So the name of the metal should be cobalt. Okay. So name of the metal should be cobalt, and here the oxidation number will be in Roman number. Okay. And if the coordination compound is in negative form, that means anion, then the in and suffix that ate will add. That means if the coordination compound of cobalt is anion, that means we will write cobalte. Okay, cobalte. So same thing. If the ligand, then third rule will be if the ligand is suppose I am taking chlorine or amine. This is in 4 amine is there, so it should be name is tetraamine. Or if the ligand is in 2, then it di. If the ligand is in 3, then means tri. Or suppose again, if the ligand already has the by di name in their naming, that means suppose I am taking ethylene diamine, already di is there. So in that thing, if ethylene diamine is in 2, two in compound it is in 2, then we tell it as bis. If it is in 3, then we call it as a tris. And if it in compound is 4, then we call it as tetrakis. Okay, so that okay. After that, yes, that will be the rule for nomenclature of coordination compound. Yes, sir. हाँ सर,
यस
ऑलमोस्ट।
यस, एग्जाम्पल बताइए किसी का आईपीएससी नोमेनक्लेचर, जैसे एम्बिडेंट लिगेंड है,
यस।
लिगेंड है, उनके
हाँ सर,
बताइए कुछ एग्जाम्पल आईपीएससी नोमेनक्लेचर।
suppose I am taking this Cl minus ligand, then our name will be, we can write it as chloride also, chloro also, or chlorido. Okay, if anionic ligand is there, we can write it as chloro or chlorido. If that means amine, ammonia is there, ammonia is a ligand, then we call it as AMMINE. And if there is water, the name of water in coordination complex is, yes, ligand of water name is aqua. Okay, aqua. Suppose I am taking for what it was for, suppose I am taking the bidentate ligand NO2 minus. It can donate through nitrogen also, and it can donate through oxygen also. If it donates through nitrogen, then its name should be nitrito N. And if it donates through oxygen, then its name should be nitrito O. Okay. And suppose I am taking another bidentate ligand SCN minus. So if it donates through, it can donate through sulfur, it can donate through nitrogen. So if it donates through sulfur SCN minus, then its name should be thiocyanate. Okay, thiocyanate. And if it donates through nitrogen, then its name should be isothiocyanate. Its name should be isothiocyanate. Yes, that is the main basic idea of nomenclature or rule of nomenclature. Now I am taking one example. That is CONH34Cl2. Okay, now I am taking one example, that is CONH34Cl2, and here I am taking SO4. Okay, so here the compound is the coordination compound is cationic. So first we will calculate the oxidation number of cobalt atom. So I am taking cobalt as X, ammonia has no charge, and chlorine has -1 charge. So -1 into 2, and minus sulfate has -2 charge. So whole charge will be 0, and X equal will be +4. So I am taking this X equal will be +4. So cobalt has oxidation number here +4. Okay, just I am taking, since I am taking the normal example, so its oxidation number is high, but don't take seriously. So now here two ligand is there, amine and chlorido. Okay, so first we will come with alphabetical order. So since this is a heterolactic complex, so there is two ligand, ammonia and chlorine. So alphabetically ammonia will come first, then chlorine will come second. So ammonia is in 4, so tetra amine, and chlorine is in 2, dichlorido. ठीक है, tetraamine dichlorido. Cobalt oxidation number is 4, and the counter ion is sulfate. That will be the naming of this complex. Yes, sir. Yes, sir.
Yes, good. Yes, one example from my side. Yes, CONO2 का whole 6 3 negative. What the IPSC name of this complex?
Okay, CONO2 the whole 6, then 3 minus. Okay, so here NO2 is in minus form, that means NO2 has charge of minus, NO2 minus. So that's why we will consider first, we will take the oxidation, we will calculate the oxidation number of cobalt. So X -6, whole charge is -3, so X equal to +3. So cobalt, this complex is +3. Okay, and since the complex, first thing, the complex is anion. Okay, First thing, the complex is anionic. So this name will come like cobaltate. So NO2 is of 6. So hexa 6 NO2. So here, since nitrogen is there, so I am taking that it binding through nitrogen atom. So hexa nitrito N cobaltate. Hexa nitrito N cobaltate 3. That will be the name of this complex. Hexa nitrito N cobaltate 3. Is it okay, sir?
Yes. Yes, good. Next, move on. Next topic is metal ligand bonding and metal ligand bonding and theories. So first of all,
Yes.
BBT. What the main application of BBT? Explain.
Yes, sir. The main application of VBT is that from VBT we can determine the structure. That means the structure of the complex. Okay. So actually VBT is based on covalent bonding character of metal ligand, covalent bonding character of metal and ligand. So from VBT we can get the hybridization. And the structure of the molecule. That means arrangement of the ligand around the metal. Arrangement of the ligand around the metal. We can calculate from there. Yes, sir. And we can calculate about the diamagnetic character and paramagnetic character of the complex also.
Yes, what the difference between tetrahedral, octahedral, square planar complex from BBT?
Yes, sir. So from BBT, we get to know about the hybridization concept. Okay, if the ligand, use that means 1 4s orbital and 3 4p orbital, then its hybridization becomes sp3, and then the structure of the complex will be tetrahedral form. Okay, if the complex use 2d orbital and 1s and 3p orbital, then this hybridization will be sp3d2, and the complex structure will be octahedral. Okay, and if the complex use 1d orbital and 1s and 2p orbital, then the complex will be square planar. Square planar. Okay, so in that, suppose I am taking one example, NiCl4 2 minus. Okay, NiCl4 2 minus. So NiCl4 2 minus, I am not going through brief. That means explanation. NiCl4 2 minus nickel with the chloride ligand use s orbital and 3p orbital. So its structure will be tetrahedral form. And if suppose I am taking another example of nickel, that is NiCN4 2 minus, then the hybridization will be dsp2, and it is square planar. Hybridization will be dsp2 and it is square planar. If suppose I am taking COCl6 3 minus, the hybridization will be sp3d2, and it will form octahedral complex. Okay, in tetrahedral and square planar complex, the coordination number of metal is 4, and in octahedral complex the coordination number of metal is 6. That is the main difference between tetrahedral, octahedral and square planar complex. Yes, sir.
Yes. Why is tetrahedral is always high spin complex and octahedral is both high and low, and a square planar is always low spin complex? What the reason? Explain.
Yes, sir. Okay, sir. In tetrahedral, that means the ligand, or since in tetrahedral the ligand is only 4 ligand we use, so that's why 4 ligand, the crystal field splitting. Okay, the crystal field splitting will be less. That's why that since that crystal field splitting for tetrahedral complex will be less, so electron can easily jump to the, that means excited state. So easily jump to the T2 state. So that's why electron cannot pair up. So that's why we always get high spin complex for, that's why we always get a high spin complex for tetrahedral complex. Okay, in the octahedral complex, we use 6 type of ligand. 6 coordination number is 6, that means 6 ligand is used. So the crystal field splitting will be less. Crystal field splitting will be more, and therefore, if the ligand, so I am telling it as strong. If the ligand is strong, if the ligand split the d orbital into very high level, then the electron cannot jump to the excited level or easy level. So that's why electron can easily pair up in the lower level. So that's why in octahedral we can get high spin and low spin complex both. If delta O greater than pairing energy, then we always get, if delta O greater than pairing energy, then always we will get low spin complex. If delta O less than pairing energy, then we will get high spin complex. Delta O greater than P, low spin. Delta O less than P, we will get high spin complex. Okay. In square planar, basically, the splitting, again I am telling, the splitting will be more. And square planar complex is formed basically by strong field ligand, and the metal has the highest, high surge in there, so its splitting will be more, and that's why it always form high spin, low spin complex. Yes, sir. I don't think so that square planar explanation is up. That means is okay, but स्क्वायर प्लानर का एक्सप्लेनेशन थोड़ा गड़बड़ हुआ है मेरा, वो देखना होगा. स्क्वायर प्लानर का एक्सप्लेनेशन आई थिंक आई हैव गिवन यू रॉन्ग. बाकी तो ये दोनों ठीक था आई थिंक.
वंस अगेन रिपीट करना, क्या रॉन्ग था, दोबारा एक्सप्लेन करना.
सर स्क्वायर प्लानर का आई थिंक रॉन्ग बोला मैंने.
वंस अगेन
आई हैव, यस सर, दैट मींस स्क्वायर प्लानर कॉम्प्लेक्स. हां सर,
हाँ वंस अगेन रिपीट कीजिए, कोई प्रॉब्लम नहीं है.
हाँ सर, square planar complex is basically formed by strong field ligand, and the metal has high oxidation state. That's why square planar complex are always low spin, and the crystal field splitting will be more. That's why I think. Yeah, not proper explanation. I think that is. ये मतलब square planar का देखना होगा. बाकी तो ये दोनों ठीक था. ये मतलब गड़बड़ है.
स्टेबिलिटी ऑर्डर क्या है इनमें?
हाँ सर,
स्टेबिलिटी ऑर्डर.
Stability order, sir, I don't know that. Stability order, I think octahedral का ज़्यादा होगा, tetrahedral
स्क्वायर प्लेनर का ज़्यादा होता है ना, स्क्वायर प्लेनर, ऑक्टाहेड्रल, टेट्राहेड्रल.
yes sir. That means first आएगा square planar, then आएगा octahedral, then आएगा tetrahedral. Yes. Okay sir, thank you for this.
लिमिटेशन क्या है बीवीटी की? व्हाट द लिमिटेशन ऑफ बीवीटी?
Yes sir, basically BBT, what was it? BBT is basically covalent bond concept. First thing, it cannot explain the spectra of the complex. Why coordination complex are colored? It cannot explain the colored experiment. And then again, one thing that it puts. Suppose I am taking NiCl4 2 minus. Suppose NiCl4 2 minus and NiCl4 2 minus. It cannot explain why NiCl4 2 minus is that means uses outer d orbital, that means 4d orbital, and why NiCl4 2 minus that means use inner d orbital. That means it cannot explain the that means violation of Hund's rule. Basically, it cannot explain the violation of Hund's rule. That's why it is that are the main two limitation of valence bond theory. Is it okay, sir?
Yes. It cannot be explained the electronic spectra of the complex. It cannot be explained the reaction rate. It cannot be explained the CuNH3 all for 2 positive negative complex. Cannot be explained the nature of ligand. Cannot be explained the pairing of electrons.
Yes. Yes. Nature of ligand, pairing of electrons. That is violation of Hund's rule. It cannot explain. That is the main thing. Yes.
Next, move on CFT or the application of CFT. Explain CFT briefly.
Yes, sir. So CFT is basically with this covalent bond character we can explain, and in CFT we that means we take metal and ligand as the point charge, and there is a electrostatic attraction between the metal and ligand. There is a electrostatic attraction between the metal and ligand. So if ligand is approaching the metal, okay. Basically in when all the metal are approaching the metal, all the d orbital are in degenerate form, and if so here 5d orbital is there, so 5d orbital 3d orbital are between the axis and 2d orbital are along the axis. Suppose ligand approach through between the axis, then the 3d orbital, that is dxy, dyz, and dzx orbital will get repulsion, will feel repulsion, and the energy will increase. Okay, and if ligand coming along the axis, then the 2d orbital, that is dz square and dx square minus y square orbital will get repulsion and feel repulsion, and it will increase the energy. So there are that means when ligand is not coming, then all d orbital are in degenerate form. When ligand approaches the metal, then the d orbital is split into two forms. One is T2G and one is triply degenerate, and another one is doubly degenerate form. Okay, so the main application of CFT is CFT can explain the color of the, that means DD transition. That means CFT with the help of DD transition can explain the electronic spectra of the complex. Okay, electronic spectra of the complex. It can explain the that means high spin and low spin complex also. That means paramagnetic diamagnetic character of ligand also. It gives basically a spectrochemical series where strong field ligand can pair up the energy, and where weak field ligand cannot pair the electron. That is the main application of crystal field theory. Yes, sir.
What is spectrochemical series? What are the uses of spectrochemical series in?
So spectrochemical series is that means which can explain the strength of the ligand. Okay, which can explain the strength of the ligand. With the help of spectrochemical series, we get to know about that means nature of ligand. Basically, nature of ligand. Which ligand is strong field, which can split the d orbital into more, or which cannot split the d orbital into that means less. Spectrochemical series is basically in between water is there. Before this, all are and this. Here all are weak field ligand, and here all are, that means, strong field ligand. Basically, we call it as strong field ligand. Water is the main reference. Let's see. Is it okay, sir?
Yes. What is pairing energy? What the main
Yes, sir.
application of pairing energy?
Okay. So, sir, pairing energy is basically what that means the minimum amount of energy required to pair up the electron. Okay. Suppose I am taking CO Ni, okay, NiCN6 NiCN6 4 minus. Okay, suppose I am taking NiCN6 4 minus. So nickel has the +2 charge, and cyanide is a strong field ligand. Nickel +2 charge, so it has electronic configuration of 3D8. So at first, all the d orbitals are in degenerate state. When the ligand approaches, since it's covalent, since it's 6 coordinate octahedral format, okay, the 2 d orbital will split to upper position and 3 d orbital will split to lower position to balance the energy. Okay, so here that means D8 system. Okay, in D8 system, the electron, first of all, in ground state, electron stay like this: 1, 2, 3, 4, 5, 6, 7, 8. Okay, okay. So in when the cyanide ligand, come, then it all the electron, that means all electron, that means it pair 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here I am taking this as, that means first this one, then this one, then this one, then this one, and then this. Okay, so here the 3 electron is by force we pair, so that's why we call it as pairing energy. That means the minimum amount of energy required to pair up the electron, that is called pairing energy. It is, I don't think so, the proper explanation, but I think almost okay.
Yes. Yes, good.
Okay, sir.
Next, MSc-CHEM. What is John-Taylor distortion?
Yes, sir. John-Taylor distortion is the John-Taylor distortion, basically the distortion present in a molecule or ion, the molecular ion which has unsymmetrically filled d orbital to lower its energy, to lower its degeneracy, or to lower its symmetry. That means basically the structure of octahedral complex is distort to lower its energy, or to lower because due to John-Taylor distortion, the energy get destabilized. That means energy is increasing. So to stabilize this, the structure will be structure should lower its symmetry, or structure should lower its degeneracy, or structure should lower its symmetry. That means that is the main theory for John-Taylor distortion. I have forgot the exact definition. Lower its degeneracy, lower its symmetry, और एक था lower its energy. Yes, 3 था.
What is the difference between dynamic and static?
Yes, sir. Yes, sir. Suppose that means there are 2 John-Taylor distortion is there. One is static and one is dynamic. Static John-Taylor distortion is this. We can calculate it in any, that means in any time. That means that is in permanent, like permanent effect. That is static John-Taylor distortion is permanent effect, like and we can calculate in solid form, we can calculate in liquid form, in any form, and we can calculate the static Jahn-Teller distortion in low temperature also, in high temperature also. But the dynamic Jahn-Teller distortion is not like that. It is not a permanent effect, or we can calculate only it in low temperature only. Okay, when the electron, that means when the that means unsymmetry is filled in easy orbital, then we call it as static Jahn-Teller distortion. And if the unsymmetry is filled in T2G orbital, then we call it as dynamic Jahn-Teller distortion. Yes, that is the main difference between static and dynamic Jahn-Teller distortion. That means if the configuration has T2G4 configuration, okay, or T2G4 or T2G2 configuration or T2G1 configuration, then it will show dynamic Jahn-Teller distortion. Okay, dynamic. And if it show T2G3 and EZ1, then it will show static Jahn-Teller distortion. Yes.
Okay, what the application of crystal field stabilization energy?
Yes, sir. With the help of crystal field stabilization energy, we can calculate that means enthalpy of hydration. Enthalpy of hydration. Main application is enthalpy of hydration, I think. Yes, main application. Enthalpy of hydration is or एक था सर. Enthalpy of something था सर. मतलब enthalpy का है कि we can calculate enthalpy from CMSC. Enthalpy of hydration और एक था. That I forgot application of it. Okay, sir.
What is spinal? What the main application of spinals?
सर स्पाइनल वहां तक मैंने अभी तक पढ़ा नहीं सर. ये मतलब लिगेंड की थ्योरी तक ही पढ़ा था, तो वहां तक मैंने पढ़ा नहीं है. तो कल मतलब देख सकता हूँ तो अच्छा रहेगा सर. सो स्पाइनल बेसिकली ये एक फॉर्म था M, yes, that is AB2O4. That means one A should be in class 2 or B should be in class 3 for normal spinal. जहाँ तक मुझे याद है, that means A should be in octahedral and B should be in tetrahedral form, tetrahedral hole of the lattice structure. And if half of the octahedral is occupied by B3 molecule, B3 atom, okay, then it is called inverse spinal. MgAl2O4 is a example of normal spinal, and Fe3O4 is an example of inverse spinal. That means with the help of CFSC, we can calculate if the CFSC value is more stable in plus 2 state, then plus 2 state in octahedral, then octahedral hole will occupy. If it is not, then tetrahedral hole will occupy. Suppose it was like that, but I forgot. That means I cannot explain. I can calculate, but I cannot explain now. That is, I have to check this one, sir. Sorry for that. Sorry for now.
LFT, ligand field theory. What is the main application of LFT? First of all, limitation of CFT.
Yes, sir. Sir, CFT का limitation जो था, मतलब how, that means it cannot explain the covalent nature of complex. Okay, it takes only the ionic character of, that means crystal, that means coordination compound, and it cannot explain the covalent nature of complex. And it also, that means how some ligand is strong field and how some ligand is weak field, it cannot explain. It only give the spectrochemical series, but how spectrochemical series came, it cannot explain. That is the main drawback of crystal field theory. But the ligand field theory can explain all these things. Ligand field theory can explain all these things. Yes, sir. Ligand field theory can explain the color of the complex also. That means ligand to metal charge transfer, metal to ligand charge transfer. All this can explain by ligand field theory, and why that is NCS minus. Suppose I am taking NCS minus, SCN minus is there. Okay, I am taking this ligand. I am giving one example of ligand field theory. Okay, SCN minus. SCN minus is an evidential ligand. SCN, it can donate through sulfur also, and it can donate through nitrogen also. When it donate through sulfur, it acts as weak field ligand, and when it donate through nitrogen, it acts as strong field ligand. Why it happened like this, crystal field theory cannot explain. But with the help of ligand field theory, we can explain the strong field and weak field nature of sulfur and nitrogen. Yes, sir.
Yes, next move on ligand field theory, application of LFT.
Yes, sir. Application of LFT basically that it explains the that means all the charge spectrum, that means all the electronic spectrum which are what does it that means ligand to metal charge transfer, metal to ligand charge transfer, or it can explain the strong ligand nature. That means it prove the spectrochemical series. That is the main application of LFT. And it can explain the covalent nature of complex also.
Yes, sigma bonding in octahedral complex, sigma bonding tetrahedral complex forms LFT.
Yes, sir.
Explain.
हाँ सर, सिग्मा बॉन्डिंग मतलब जो लिगेंड रहता है ना, देखना होगा ये तो मतलब एक्सप्लेन अभी तो मतलब ये डायग्राम तो नहीं कर पाऊंगा, ये मतलब सिग्मा बॉन्डिंग बेसिकली लिगेंड that means ligand orbital are divided into three. That means one is A1G and one is P1G and one is I think P2G. Yes. Okay. So for sigma bonding, the ligand use A1G orbital, and the metal use EG orbital. Okay, I have to explain that. That means diagram draw करना पड़ेगा ये.
Yes.
डायग्राम तो अभी तो मतलब एग्जैक्टली याद नहीं है, लेकिन ये मतलब हो जाएगा, मतलब
कोई
अच्छे
दिक्कत
से कर
नहीं
लिया.
है, आगे
हाँ सर,
बताओ.
नेक्स्ट क्लास. हाँ सर, हाँ सर.
Hemo diagram for sigma bonding in tetrahedral, octahedral, scattered.
All I have read already. I have read all these things already. That means ligand field theory. But मतलब डायग्राम तो मतलब आपको दिखा सकता हूँ, मतलब बोर्ड मतलब वॉल पे लगा हुआ है लेकिन अभी तो मतलब थोड़ा रिवाइज करना होगा ये, क्योंकि हो जाएगा. और सर एक बात पूछना था आपको, ये मतलब अभी और क्या क्या टॉपिक मतलब पूरा होल रिवीजन करना होगा मुझे, और कोऑर्डिनेशन देख रहा हूँ मतलब अभी तो.
कोऑर्डिनेशन कर लीजिए, अभी कोऑर्डिनेशन में टाइम है. थ्योरीज है, कलर इलेक्ट्रॉन ट्रांसफर, स्पेक्ट्रा है, मैग्नेटिज्म में, रिएक्शन मैकेनिज्म, तो नेक्स्ट क्लास में यही हो पाएगा.
हाँ सर, हाँ सर, नेक्स्ट क्लास तक तो ये
और टॉपिक है, उसके बाद जो और टॉपिक है उनको हम डिस्कस करेंगे.
हाँ सर, और मतलब ज्यादा ध्यान देने वाला टॉपिक कौन सा होगा अभी, मतलब इम्पोर्टेंस है.
उसके बाद जो भी आप करना चाहे, जो भी आपको लगता है वो टॉपिक आप कर लीजिए, जो बचा हुआ है वो.
और ऑलमोस्ट सर हमने तो अराउंड 6 टॉपिक तो अच्छे से कर लिया था.
यस,
केमिकल
वो कर
बॉन्डिंग.
लीजिए, बाकी रैंडम कर लेंगे. यस.
हाँ सर, हाँ सर, अच्छे से देख लिया है मैंने. ठीक नहीं होगा सर, अभी तो मतलब ऑर्गेनोमेटेलिक भी सब देखना होगा पूरा.